Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help show you how to find the sum of a geometric sequence. So example number one, we're going to look at this animal here, the geometric sequence 2, 4, 8, etc. out to some value a sub n. We're going to look for the sum of this sequence out to n equals 6. So for starters, the sum of the sequence usually gets its own variable here. We're going to call this s sub n here. So s sub n is going to equal the sum 2 plus 4 plus 8 plus out to a sub n. And we're going to try to calculate this sum out to a value of 6. Now the first method to use here is what I'm just going to call brute force. If you just follow this sequence out, I already did this on the right. Here it is. 2, 4, 8, 16, 32, 64. There's 1, 2, 3, 4, 5, 6 of them. And if you can just go through and add these all up, we get a buck 26 here. So that's method number one. But method number one, would work really well for small values of n and pretty easy sequences here. What we want to do here is find a little bit more sophisticated method that will work for much larger values of n and not make us go through all of this rigmarole here. So what I'm going to do here is I'm going to take this guy here and I am going to replace that a sub n with a formula for a sub n. All right, and that a sub n, because it's geometric, is going to equal 2 times r, and the r you can get by taking the ratio, which is 2 to the n minus 1. All right, so we're going to go through and I'm going to show you a couple little tricks here for finding the sum, and it's kind of a three-step process. Step number one, multiply both sides of this equation by r, whatever r is. Left-hand side of this equation is now going to be, right, r is 2, so it's going to be 2 times s sub n on the left equals right-hand side, multiplying everything through by 2. That's going to become a 4, an 8, a 16. Right? Last term. Now when we take this and multiply by 2, that's going to be now 2 to the power of n, not n minus 1. Because again, if I multiply this by 2, and remember, when you multiply, you add exponents. 2 to the n minus 1 times 2 to the first would be just 2 to the n. All right. Step 2. Take what I'm going to call equation 1, subtract equation 2. Left-hand side, s sub n minus 2 times s sub n. We'll just write that exactly the way I said it, basically. Equals. All right, right-hand side. Now, when we look over here now, 2, and I look here, I don't see a 2, so let's just leave that alone. However, 4 minus 4 is 0, 8 minus 8 is 0, 16 minus 16 is 0, and that pattern is going to hold all the way to this last value. This value here, right, when we look right here, the value right before it is going to be 2 times 2 to the n minus 1. So this will have a subtraction partner as well, if you will. A subtraction partner, I like that term. But this guy won't. There's nothing here to subtract this and give us a value or give us a 0. So that term stays, and it's now going to be negative. Because remember, I'm taking what I'm calling equation 2 and subtracting equation 1. So what I have now, this formula, this equation here has really simplified nicely, because if I take s sub n minus 2 times s sub n, we get minus 1 times s sub n equals 2 minus 2 times 2 to the n. So I've got this really nice easy formula now to calculate my sum for any value of n. Using n equals 6, we're going to have 2 minus 2 times 2 to the 6th power. There's lots of 2's in that equation. And if you solve that for the sum, you get 126. When you put this, if you're following along and you put this in your calculator, you actually get negative 126, but then you have to divide it by a minus sign. And you notice that that 126 matches our previous work. All right, so that's kind of the method. You write out a formula for s sub n. Oops, actually that was this before I multiplied it by 2. Right, you multiply that formula by r, whatever that value is, subtract, and then you can typically just algebraically solve for s sub n. I'm going to go ahead and pause this video here and make up another example and come back to you. All right, I'm back, and we are, again, we're going to talk about the super exciting concept of finding the sum of a sequence. So I've got some sort of sequence here. Let's see, -2, -8, -32. It's a geometric sequence. Getting from here to here is times by 4, times by 4, times by 4, out to some sort of a sub n. First thing I'm going to do is, write out my formula for a sub n. A sub n is equal to -2 times r to the n. The r in this case is 4, and my apologies, not n, and minus 1. Again, if you start at n equals 1. I'm going to make sure that works real quick. So the first term would be for n equals 1. Put a 1 here. 4 to the 0 is 1 times -2. Okay, we're good. All right, then I'm going to write out a formula for my sequence. Right? So we have s sub n is equal to -2 plus -8 plus -32 plus, and I'm just going to put dot dot dot, this last guy, -2 times 4 to the n minus 1. Right. Remember the trick now. Multiply by r, so this is going to read 4 times s sub n equals -8. Right, coming from multiply that by 4. Multiply that one by 4, -32. I'll just put dot, 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 dot. Multiplying this by 4, -2 times, and when we multiply this by 4, it becomes 4 to the n. Okay, so we did our times by r. Now we've got two equations, 1 and 2. Then we take equation 1, subtract equation 2. So when we take this guy minus this guy, we are now going to have -3 s sub n equals, right-hand side, -2, there's nothing to subtract, we leave it alone. -8 minus a -8 is 0. -32 minus a -32 is 0. And again, partner, 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 partner. This one will have a partner as well. So that very last one, I'll just put dot, is going to be a 0. This one doesn't have a partner here, so you can think of it like 0 minus 2 times 4 to the n. So that's going to be plus 2 times 4 to the n. Got to be very cautious about these plus and minus signs. Remember, we're taking this equation, subtracting this equation. And when we take 0 minus a minus 2 times 4 to the n, we get positive 2 times 4 to the n. Alright, so now we got this really nice quick equation here. -3 times s sub n equals -2 plus 2 times 4 to the n. And now we will just use the appropriate value for n. The original problem I'm looking at is for n equals 7. So -3 times sum out to 7 is equal to -2 plus 2 times 4 to the 7th power. Now I'm just going to calculate a value divided by -3. Give me a moment. Alright, and I get it. -10,922. Alright, this stuff is exciting. So I think what I'm going to do is just do one more example. I was going to stop it there, but I'm going to do one more example if you don't mind. So let me pause that, write that example. Alright, so I'm back, and we're going to take a look at the sequence described by -4, 8, -16, and so forth. Alright, first things first, you have to recognize this as a geometric sequence. It is a multiplication that is getting us from here to here, and then here to here, and then here to here, and so forth. We're going to want that a sub n value, no doubt, or a formula for the a sub n, and we get that by taking our starting value times the r value, the ratio, this guy to this guy, or you could do this guy to this guy, doesn't matter. That ratio is -2 to the n minus 1. Alright, and again, this would be true starting at n equals 1. Now, the sum of this sequence is going to equal -4 plus 8 plus a -16 plus, alright, plus our last value, -4 times -2 to the n minus 1. Then remember our trick here. Multiply this thing by r. Now in this case, r is -2, so we're going to have -2 times s sub n equals. When we multiply that by -2, we get 8 plus a -16 plus, forgive me for not putting parentheses in, but let's see, that next one is going to be 32. You know, I don't need any more. Multiplying this last one by -2, we're going to have -4 times -2 to the n. And again, because we're taking this, multiplying it by -2, right? And that's going to make that -2 to the n. All right, next, take equation 1, subtract equation 2. So, being very cautious here, when we take this guy, subtract this guy, and if you don't mind, I'm just going to shortcut that to 3 times s sub n. When you take 1 somethings minus a -2 somethings, you would get 3 times the somethings equals. Right-hand side, there is nothing to take from this guy. Let's take this and think of it as -0, I guess. So let's just read that -4 there. But 8 minus 8 is 0. -16 minus a -16 is 0. And again, there's going to be a bunch of these, what I would call subtraction partners. This one will have one right before this. Remember, the term that's just before this is going to be -4 times -2 to the n minus 1. These will be gone. All right? And then there's no partner here for this guy, so you can think of it as 0 minus this thing. So that last term is going to be plus 4 times -2 to the n. And again, that'll be a plus now because we're doing equation 1 minus equation 2. All right, so this 3 times s sub n, this is going to shorten up really nicely now, is going to equal -4 plus all the zeros, let's just leave them out. And that last term is going to be 4 times -2 to the n. We were interested in the sum out to n equals 5, so 3 times the sum of n equals 5, -4 plus 4 times -2 to the 5th power. And now I'm just going to wash this through the calculator and divide it by 3. Let's see what we get out of that. I get -44. All right, so hopefully that's correct. Again, the purpose of this video was how to find the sum of a geometric sequence. I hope that this has helped demonstrate that for you. Have a great day.